Well, it looks like it's 10 right on the dot, so we're gonna get things started here. Good morning, everyone. Welcome to the long coffee break. This week we have Brett Duffy from CASPR joining us. CASPR delivers innovative disinfection technology. And Brett's here to present on some of CASPR's product offerings. Brett, take it away.
All right, well, welcome. Thank you for having me. I'm excited to kind of show a different side of disinfection and things than you might have seen in the past. So we're going to move right on to the next slide here. Oh, and it's not looking good. Of course it's not looking right. Why is come on. It's just not doing it. All right, well. This was a animation of bananas, and the top bananas are oh, there they go. The top bananas are in a container with CASPR, and the bottom ones are not. And the question is, which bananas would you like to eat as we get to day 7 here? And I think the general answer is probably going to be the ones on the top. The bottom ones are pretty brown, unless you're making banana bread or something. And, you know, this is surprisingly important when you tie this into indoor air quality, because if you know about fruit, the ethylene is what causes them to ripen. And this is visual that the CASPR is eliminating that ethylene so that we don't have that quick ripening that's happening on the bottom. So when you say the topic for today is indoor air quality, and we're going to leverage it into more product out there. Here's our competitive advantage of CASPR. We are infection control, so we reduce the risk, both air and surfaces of infections. We're an IEQ leader. We were the first product tested to the new ASHRAE 241 standard. With proven results, both safety and efficacy, which we'll talk about in a few minutes. And then we also provide cost savings. We can reduce that amount of outside air per the IAQP and provide both energy efficiency and reduced equipment cost. And I know it's a little different there because you guys run economizer mode because of your fabulous climate all the time. But let's talk about and why IQP can be the key. So we do get the ability to reduce air handler capacity, which is where you get that upfront cost because we're not having to use that outside air as much per the IAQP. We also, if you aren't running the economizer too much, then you can get some reduced energy usage. Probably not as big of a selling point for you guys. And then we are a direct replacement for ionization. So I know that ionization has been in the industry for a long, long time. We are going to provide ionization replacement technology. We are not ionization. And we're going to provide it for effectively the same cost and significantly more benefits. We will look at moisture reduction and the impact on moisture. Never mind. You guys in Colorado, you don't do moisture, right? So we'll skip that over. Let's look at some of our customized solutions here of what we've got going on. Most of the time, we're going to recommend the Medic, which is our duct-mounted unit. We put that both in air handlers and in ductwork. It just depends on the configuration of the system. We have tested that unit to every possible safety standard you could imagine, and also to effectiveness. It basically, the reason we like to use that one is because it utilizes the moving parts of your HVAC system and doesn't have any moving parts of its own, which I appreciate. It's a lot less to deal with. The blue tile and the transit are self-contained units. You can see the blue tile just pops into a 2x2 drop ceiling spot. We use this in cases where maybe we don't have ventilation the way that we would like it to be. We don't have HVAC systems feeding the way we would like them to be. But we also use it sometimes just as a visual cue. One of the questions I get asked all the time is, can I tell that it's in the HVAC system? Well, unless you're dealing with an odor problem, you're not going to be able to really tell that our system is in there, because it's just cleaning the air and the surfaces. And yeah, you're not going to get as sick and those sorts of things. But at the end of the day, you aren't going to be able to notice. Like, you aren't going to walk in and there's a different smell necessarily. And so sometimes we put the blue tile in the front foyer, lobby, waiting area, just to give that, visual impact of that we're doing something in this building to help protect you. The Transit is a smaller unit. It was originally designed to be used in ambulances. We are standard equipment on a number of ambulance manufacturers, OEM equipment, and we leverage that both in mobile applications like ambulances, school buses, those sorts of things. But we can also use it in a small indoor space, sometimes like a walk-in fridge if we've gotten issues going on in there. Those are places where we might use that. The CASPR application, if I go to the next slide, well, maybe I go to the next slide. Here we go. The CASPR application. So unit selection for the medics, which again is what we try to go with, is focused on CFM coverage and then kind of a correlating square footage coverage. It's not an exact science because we are looking at producing 0.01 to 0.04 parts per million of hydrogen peroxide. As you see there on the screen, we are taking in oxygen molecules and moisture molecules, and then we are converting them into hydrogen peroxide gas molecules. Those molecules are extremely safe for every environment. They're significantly lower than the OSHA safety standard. So we're talking 0.01 to 0.04 parts per million. The OSHA safety limit is 1 part per million over an 8-hour shift. So we're way below those numbers. And we have tried to go more than that, but we've not been able to get more hydrogen peroxide to be stable in that gas phase in any environment because it oxidizes itself. So we can't overdose. So I see, you see here that the M14 covers around 14,000 square CFM, and the M6 only covers about 5,000 CFM. I can still put an M14 in that same unit that's only doing 5,000 CFM, and I'm not going to create a hazardous situation. I'm not going to cause any damage. I'm not going to create any issues. The only reason I wouldn't do that is from a cost perspective. Obviously, the 14 costs more than the 6, so why would we use the 14 if we can use just the 6? And so that's really where we look at from those perspectives. The other thing that's interesting about our technology in comparison to some other indoor air quality products out there is that because the hydrogen peroxide molecules will live for 30 to 45 minutes, you don't have to just place them in the individual units. So for example, if you have a water source heat pump system or a fan coil units spread across your facility, but they're all being served by, maybe 1 or 2 central outside air ducts, we can go into that outside air system as opposed to having to put a unit in every single one of the fan coils because of that lifespan that we have, and we're going to make it to that unit and we're going to make it into the space. That's the key for our technology. Our technology gets to the space. It's going to fill that room as it comes out of the duct or out of the blue tile or whatever. It's going to fill that room from one edge to the other. Because remember from chemistry class back in the day, if you put a gas into a container, it's going to expand to fill that whole container. And so we are going to see that 0.01 to 0.04 parts per million expanded across the entire space. That means we aren't relying on airflow. A lot of indoor air quality products rely on airflow. If you have to get it back to the filter or to be treated in the HVAC system or in the duct, you're relying on airflow to bring those pathogens and contaminants, whether you're talking VOCs, you're talking viruses, bacteria, whatever, all of that has to come back to the space where that treatment is happening. And the air is the only thing that's going to move that. And if that stuff is falling out of the air or getting stuck in air pockets that aren't moving around, they're landing on desk, we know that there's lots of things that are transmissible via surface as well. And we'll look at a specific one here in a minute. So to give you a few little details on the Medic duct-mounted technical specs, it runs anywhere from 120 to 277. We do a lot of retrofits. That's part of the reason why we have that native variance on the power input. The different size units do run different wattage, of course. In ongoing operation, they run somewhere between 30 and 60 watts continuous. There is zero pressure drop when it's installed into the right size ductwork. You can create a situation where it's going to create pressure drop, but it's typically, you know, if you're putting a 14-inch in a 13,000, 14,000 CFM unit, you're not putting it in a 6 by 14 duct. So you're not going to see that kind of pressure drop. We have a good temperature operating range, and all of these units, the commercial units, come with an extra bulb and a cell. And so that way you're getting, the bulb has to be changed every 18 months-ish, and the cell about every 3 years. I'll be brutally honest with you, the 18 months is a absolute protective number from the standpoint of that is when the energy curve starts to curve down from the bulb's energy output. That energy output reflecting off of the cell, the four-sided honeycomb, is what causes that catalyst to create the catalytic reaction. We like to change it at 18 because then there's absolutely no dip in it. The reality is that you can go 24 months with it if you want. You just, depending on the situation, you may or may not want to go beyond that 18 months. And we're happy to talk with you about that. Warranties, like I said, 5 years on the ballast, although we've been in business since 2016, and I don't know of a single ballast that's ever failed. If it comes on when you plug it in and start it, it's good to go. Same with the bulbs. The bulbs don't typically burn out in that time frame, the 1 year time frame. They are much more likely to be burned out when you're putting them in, if somebody's touching them with their oils and such from that standpoint. All right, let's go deep scientific for a second. I'm not going to hang too long on this because I know, this gets a little dry. But ASHRAE 241, these are the test results from 2023 when we tested using that Medic device. You can see the natural decay across the top and the reduction with the hydrogen peroxide. The interesting thing about 241, it only allows you to take credit for the gap. So you're not getting any benefit for the natural decay. Both of these tests were run in a chamber without a filter and without any outside air ventilation. We wanted to isolate just this specific effect of this individual product. And you can see that in the bottom right corner there at the end of the 60-minute test, we were at 99%, 96% in a half hour, but more importantly, 70% and 80% in the first 4 to 12 minutes. And so remember that 241 is an emergency standard, but it can be applied every day if you're trying to reduce transmission rates. And if you're doing equivalent clean air, the way that we are able to clean air and provide equivalent clean air here, you are able to reduce those transmission rates. Take a school where little Jimmy and little Jenny are sitting next to each other, and Jimmy starts sniffling and hacking stuff up and spreading stuff all over the place. We would much rather, if Jenny is my kid, I want a system in that classroom that's going to be able to hit 70 to 80% of that stuff coming off of Jimmy in the first 70 to 80, in the first 4 to 12 minutes, because that's going to reduce Jenny's chance of getting sick. The other thing that's important about this testing is that this is from the moment that the device is turned on. So the concentration of hydrogen peroxide in that space is effectively zero, and it takes time to build up in the chamber. And so we know that this is a very conservative result. We know that that 70 and 80 is actually probably higher than that in the real world when our device is running continuously, which is what it's designed to do. We talked about surface kills being a very big difference between our products and other products out there. Indoor air quality is important. Indoor environmental quality is even more important. One of the factors in an indoor environmental quality is that surface pathogen contamination. This is MRSA, medical resistant staph. We see this in a lot of facilities where, workouts, gymnasiums, that sort of thing. One of our examples we installed into the LSU gymnastics training facility, and they installed during COVID to help them deal with the COVID outbreak and deal with all of that. But several years later, the coach came to us and said, it's interesting that we haven't had a single case of MRSA or ringworm since we put CASPR in this facility, and we used to have an average of 2 or 3 cases a year in the team. So it's very important to look at surface kills as well. I'm going to do a real quick, because I know I'm running out of time. I'm going to do a real quick, just educational piece, because I find this very interesting as an engineer who's not an infection control person. The hierarchy, so to speak, of easiest to kill, hardest to kill in the world of pathogens. Envelope viruses are the ones that we hear about most of the time. Those are your flus, your measles, your COVIDs. Those are so easy to kill, but they're extremely contagious, which is what causes them to be an issue. Next level up, we start hitting bacteria like MRSA. A lot of these are surface borne, right? We just had a listeria outbreak here at some turkey farm in Georgia. I would love that they would have had this in their system so that they would have helped eliminate that. Fungi, mold and fungi is right there in the middle. Candida auroris, if you're in the healthcare environment, definitely an issue. But just general mold, and I know you guys are not very moisture rich out there in Colorado, but you might be dealing with some mold issues inside a space. And if you are, this is going to help you. It's not a remediation, but it's going to keep it from coming back. You see the non-envelope viruses is where the MS2 lives. That comes from the ASHRAE 241 standard. That's what they're using in that testing standard. And the reason they're using that is because, according to all the scientists out there, if I can knock out the MS2, then I can knock out everything else below it. And so then I don't have to worry about variations of the flu, for example. As we're coming into flu season this year, I know some parts of the country are really struggling. If the CDC got it right and the flu shot that you got happens to be the right one for the strain that's coming out, you're in good shape. If it's not, then you might be really struggling. We don't care what strain it is because we're only going to knock out all of those. We went one step further with the spores, which are the hardest to kill. C. diff, if you have ever been around a senior living facility or something like that, C. diff is an issue and it is very hard to kill. And I'm going to wrap it up from there and go right into our weekly prize drawing from John.
Awesome. Thank you, Brett. If you have any specific questions regarding what Brett presented today, please reach out to your Long sales engineer and they will be able to provide you with more information. This week's prize offerings are a burrito tortilla blanket, $100 REI gift card, or a Coach tech organizer. Thank you, everyone, and we will see you next week.
Thank you all.